My name is Kim Gilbert. I'm the Regional Technical Consultant for the Southeast for Automated Logic Controls. My job is to work with our dealers and branches to support design engineers with specifications and sequences and things like that. I've only been with ALC since the end of November. Prior to that, I was with Train for several years. I was actually the operations manager for the state of Georgia to oversee controls installations and things like that. So there's a lot more of you than I thought would be for 4:30 in the afternoon. So I will do everything I can to get this done by 8. So no, I know I'm standing between you guys and a cold drink, so we'll get through this pretty quickly. So what we're going to do is we're going to talk about analytics, type of analytics, FDD architecture, and how all that relates to your BMS system and how to leverage it to identify issues and look for problems before they really become issues. So to get started, let's talk about a BAS system and the traditional BAS system. Really, the traditional BAS system had two main functions, and those functions were what? Environmental comfort, and then energy savings or optimizing, how the building operates. But when you dive into that a little bit deeper and you look at environmental comfort, there's more than just temperature control. We're seeing more and more studies about having a specific environment increases productivity. A big thing we're seeing now is the user experience. What are the occupants feeling? How are the occupants able to interact with the facility? Are you guys seeing that in your practices every day? Where people talk about, hey, I've got an app on my phone that allows me to adjust the temperature, that allows me to unlock doors, things like that. We're seeing more and more of that. The other things with environmental conditions are safety, health, things of that nature. Then when you move over to cost savings, the traditional BAS system, you did scheduling, you did unoccupied set points and things like that. Now we're starting to see more things that involve demand shifting, demand limiting, and all sorts of optimization. So all of that brings us to data that comes from the BAS system. And things that are driving us to use this data are rising energy cost, legislation, green initiative, things of that nature are forcing us to look at this data and implement it to drive insights as to how we operate the building. So data is expected to be collected from a variety of sources. It can be done at the building level. It can be done in the cloud. The bottom line is there's more of a requirement for enhanced data within the BAS system. So now we have the quandary of, now we have data, and how do we change that data into information, and how do we do that to drive meaningful insights? So that brings us to analytics. Webster defines analytics as the method of logical analysis. Wikipedia calls it the discovery, interpretation, and communication of meaningful patterns in data, and then the process of applying these patterns for effective decision making. So basically, analytics is finding patterns in existing data, looking at the existing temperature, humidity, fan status, damper positions, energy use, things of that nature. And that's information that's contained in the BMS. And then we need to take that data and turn it into meaningful insights so that we can run the building more efficiently, create better environments for the occupants, and enhance the occupant experience. And one other aspect of this data and analytics, it often favors visualizations, and we'll talk about that here in just a minute. So types of analytics. There's analytics that are built into the BMS, the things that you see with graphics, the things you see with trends, the things you see with alarms. Then there's analytics that are in the cloud. Sometimes these are subscription service, sometimes it uses artificial intelligence, and then sometimes it actually takes a human engineer reviewing that data to look for trends and information. So analytics and the BMS. Data is gathered, stored historically, and then ran against a set of rules to hunt down potential operational and efficiency issues. You can run complex system-wide rules. You can mine historical data. Some issues that you do need to be aware of is the data cleanup can be cumbersome, particularly when you're dealing with older systems. And then you can also have issues with the complexity and difficulty to set up and manage it. And one last thing I do want to talk about is we're seeing more and more requirements for subscription service. And I'd be curious to get some input from you guys. I'm finding that this is more of an IT technology-driven thing that's going on. IT people seem to be more familiar with doing subscription services. Facility managers don't. So analytics in the BMS, like I said, trend data is gathered and stored in the BMS. Then a lot of times that data runs through a middleware and then goes to analytics software. So it gets cleaned up and then rules are applied to look for inconsistencies and look for trends in that data. So we talked a little bit about data visualization. We're seeing more and more requirements for dashboards with all the information that's available with analytics, continuous commissioning, and energy analysis. The nice thing with the dashboards or the data visualization is it does give you a way to do eyeball analytics. Instead of going through, sheets and sheets of Excel spreadsheets and trend data, you actually have graphics that pop up information that can easily be read and determine if there's an issue. The other part with data visualization is there's more and more people that are using this data. It's not just the BAS operator. So there's different types of visuals. The facility operator is looking for things different than a CFO. So you've got to be thinking about how to gather that data and how to display it for the various people that are going to be using and looking at the data and operating the building. So you've got very disparate audiences looking at this information. So we want to talk a little bit about how to take these analytics and then do some predictive capabilities. Monitoring weather forecast, by using that, calculating future heating and cooling demand. Using data to predict opportunities for free cooling. Consider current indoor and outdoor conditions to determine whether we should pre-cool or preheat, and when we should pre-cool and when we should preheat. When we're using weather data, another important aspect is to also be looking at utility data and being able to look at that information real time so that you can make some decisions on doing demand shedding, relax your set points in the building so that you're not using as much energy. And then you can also look at doing demand shifting, particularly if you have thermal storage or things of that nature in your system. So you're able to take this weather data in the BMS system and then use it to look for ways to relax the set points and operate the equipment more efficiently. So just some key takeaways from analytics. Look for the patterns in the data, visualize the data, know who's looking at the data, and then being able to use it for predictive control. And this is stuff that's available in the BMS or can be add-ons to a BMS system. So now I want to take a minute and talk about FDD. What is FDD? It stands for Fault Detection and Diagnostics. We'll talk a little bit about the history and the organizations involved with FDD, some of the standards, the architecture, the types, the platform, and then we'll finish up with some ongoing commissioning and how it relates to FDD. So FDD is basically defined as two parts, detection and diagnostics. And if you think about detection, detection is looking at things that have already happened. I'm away from set point or a piece of equipment has failed. And then diagnostics is looking for the root cause of the defective fault. So that's where you get detection and diagnostics. So this has been driven by a couple things, ASHRAE Research Project 1455, and then ASHRAE Guideline 36P. Both of these have to do with how buildings are operated. 36P is high performance sequences and has addressed FDD on the air side in high performance buildings and how they operate. ASHRAE RP 1455 is looking at best in class high performance buildings and how to implement automated fault detection and diagnostics in those buildings and in the BMS system. So on the air side, you have BAV air handling units, terminal units, fan coil units, water source heat pumps, things of that nature. And then on the water side, you've got differential pressure, water flow, boiler cycling, chillers staging up and down. So a real good example that I like to use for FDD is, let's take, for instance, you have a chilled water VAV air handling unit system. And let's say that you have an issue with your chiller. So what's going to happen in a traditional BMS system is you're going to get an alarm from the chiller saying, hey, I'm not working, right? Then you're going to get an alarm from the chilled water system saying, hey, my chilled water temperature is getting high. Then you're going to get an alarm from the VAV air handling unit saying, hey, my discharge air temperature is too high. Then you're going to get an alarm from all the VAVs served by that air handling unit saying, hey, we can't maintain set points in our rooms because we don't have cold enough air. So now then you've got this whole list of alarms all related to one event. So with FDD, you're able to say, hey, I don't need all the VAV alarms. I don't need all the air handling unit alarms. I don't need the chill water system alarm. I just need the alarm from the chiller, and that's what we need to go look at. So some of the organizations that have been involved with driving FDD are NIST, the National Institute of Standards and Technology. They've been developing FDD tools and software to be used in the private sector. The objective is to improve operating efficiency of the HVAC equipment by 10 to 30%. One of the issues that we have found in implementing FDD is that works great, provided you've got a proactive facilities group that's able to take these alarms and do something with them. If they don't ever do anything, you don't ever see any savings or benefit. U.S. Department of Energy has been working on this. They've been working with the National Renewable Energy Laboratory, Oak Ridge Laboratory, and Pacific Northwest National Laboratory. And they've been working on this in the public sector and are helping to drive it in the private sector along with ASHRAE. So to talk a little bit about FDD and why we're hearing a lot about it, like I said, there's organizations that are driving us towards FDD. There's a need for standardization, semantic tagging, and ASHRAE 223 helps discuss some of this. And we'll talk about this here in just a second. So the reason this is important, if you think about it, if you don't have some standards, what ends up happening with names of pieces of equipment and zones in a system? If I have my technician John go out and program it, he's going to name it something, right? If I have my technician Bob go out and program it, he's going to name it something else. So if you're trying to standardize and run these rules, if you've got all these different names, that becomes a real difficult task. So that's what's driving the standard tagging used in buildings. How many of you are familiar with Project Haystack? Okay. So that's helping drive some of the standard tagging that we need to use and how we manage that data. And then there's also something called brick schema that's helping organize how that stuff needs to be set up from, you know, a zone to an air handling unit to a chilled water system. So the real key takeaway here is when you're implementing these kind of systems, you need to have some standardized way of tagging and labeling that data. Where it gets to be a real issue is when you get into older legacy systems. that can be difficult because now you've got all this older data that has to be retagged, or you've got to come up with ways to run rules against that data and how it's named. So the FDD architecture, like I said, this can be done in the BAS system itself. It can also be done in the cloud, or you can kind of do a hybrid where you use the Internet of Things and a BAS system to do it together. You will probably, as we move towards the Internet of Things and everything being connected to the cloud, we will probably see more of that going forward because everyone's wanting to hook everything up to the Internet. So some types of FDD or analytics, physics-based modeling, which is typically done in the cloud. This is where we do statistical regression analysis approach, engineering models, efficiency curves, trending, which is typically done in the cloud. This is where we compare trend signatures to known fault signatures. And then we can do rules-based stuff that's in the BAS system. A couple things to note here is what you're also trying to do is look at how pieces of equipment are running and looking at, hey, for the last 4 months, this piece of equipment's been running like this and using X energy. And now all of a sudden in the last 2 weeks, it's using more energy. Why is it doing that? You know, we send a fault diagnostic to tell someone, hey, you need to go look at that, versus waiting for a compressor to crash or something to happen. So the whole idea is to try to get ahead of an issue before it really becomes an issue. And then the last type of analytic is a hybrid, where you use the cloud and what's going on in the local BMS system. So some aspects of the platform, you know, the type of analytics that are being used, then reporting. So are you going to do daily reports, weekly reports, what kind of summary reports, and how are you going to show those faults? It's great if you have all this information, but if you don't have any reports to show someone to look at the information, you haven't accomplished anything. And then when you get alarms, I talked about this a minute ago, there needs to be some sort of workflow on how you handle these alarms when they come in. Instead of just getting the alarm and acknowledging it and not doing anything, someone actually seeing the alarm and saying, hey, I need to go do something. So for example, you get an alarm that maybe an economizer damper is cycling too much. Go and look at it before the damper breaks. And then the last part is visualizations. Once again, it's just dashboards, so you have a quick way of seeing what's going on in the system. So this is just an example of programming in a BMS system where alarms are suppressed. I know you can't probably read that, but that is something that can be done in the BMS so that you can suppress some of the alarms and manage how the alarms are displayed and go to the user interface. This is an example of FDD reporting. You can see here we've got FDD critical categories. There are typically several categories associated with FDD, whether it be critical, whether it be in maintenance, something of that issue. So it helps identify, you know, what it is you need to go look at. This is an FDD alarming example. You can see here the economizer dampers are cycling. If this happens frequently, it may wear out damper actuators. Some common causes, the temperature control is too tight. The lubricant control loop gain needs to be widened for the temperature loop tolerance. So it gives you something to go look at in the system. Another example is an outside air or discharge air sensor failure, and then what some of the problems are, the cause of it. So FDD is not about just saying, hey, there's something wrong, but it's also about saying, hey, this is what we think could be something that you could go look at instead of getting up there and fiddling around trying to figure out what it's going to be. So the idea behind fault detection is to proactively notify and suggest diagnoses. Here's an example: the outdoor air fraction is too low or too high. Here are some things that you can go look at to see why that's happening. Visualization, once again, this is just eyeball analytics that we talked about. This is just a quick graphic that shows what fault detections you have, how many there are, which ones are critical that need to be looked at. Is this the other advantage of fault detection is you can eliminate energy hogs, because you can see where pieces of equipment are using more energy than they had been using in the past. And then you can run performance assessment rules on the equipment. So you can look at things like this rooftop unit is running more than this rooftop. Or in a situation where you have a couple chillers, one chiller seems to be running more than the other. Why is that? Why is that happening? So let's take a minute and talk about ongoing commissioning. Ongoing commissioning works similar to FDD, but it's not FDD. Typically, ongoing commissioning is a software-based commissioning tool that uses rules or models to commission or recommission the building. And it typically runs the building through its paces at a set time, usually during an unoccupied period. And it can save time and money. A real good thing to note is it works well in conjunction with FDD. Once a commissioning baseline is established, FDD is always running to maintain the baseline. How much ongoing commissioning are you guys seeing right now? I'm seeing a lot of no's right now. What's that?
Seeing the interest in it, but nobody's pulled, not too many people pulled the trigger.
What do you think has been the holdback on that?
They see it like a service.
See if it's a value to them yet. I think that's where that's going to depend on. I think you're going to see more of it. I was just saying to somebody else that you're seeing more and more building engineers that used to be part of the buildings forever, and they knew where all the bodies were buried completely on the projects. They're all going away because they can make more and more an hour across the street. So they're losing that continuity. So a lot of buildings are starting to see that engineers being review their building might be better off. So I think the trend is coming, it just hasn't hit here yet.
So I'm curious, how does that impact you guys as commissioning agents? I mean, is that something that you guys are going to try to implement yourself and promote yourself, or is that something you're going to do in assistance to someone else's service?
Yeah, we promote the ongoing commission.
What's that?
We promote it, but most of the time what we're saying is that it's used for warranty purposes, or they'll wait for a retro commission if they need it. They'll take that risk of saying, well, rather than guarantee paying for ongoing commissioning, I'll hope that everything holds together, and if I need it in the future, if my costs get out of line, then I'll go for retro commissioning. But they just don't do the ongoing.
Wow. Has anyone done any studies, and this is for my own information, has anyone done any studies on what it costs to implement a retro commissioning project versus doing an ongoing commissioning, like a life cycle cost? So some FDD takeaways: use semantic tagging when designing a building automation system so that you can standardize. You need the ability to easily identify, categorize, and document faults. We talked about the FDD being critical or being maintenance, things like that. Workflow: establish a routine to regularly check the reports. This can be a building engineer, controls, or mechanical service provider that can identify and fix those issues. The biggest thing is we don't want to just get these alarms that come in and not do anything with them. We want to make sure that something is happening and being done proactively to address them. And then commissioning and ongoing commissioning, it's a good time to implement FDD after commissioning as part of an ongoing commissioning plan. So once you as the commissioning agents are done, a baseline is established to help run rules within the FDD program. So some key takeaways: we often see customers not realizing the full potential of their BMS and the data that's in that BMS. There's lots of opportunity within the existing BMS system and leveraging that system to operate the building. Data is critical. We need to use that data to drive insights, and then analytics and FDD are critical to drive those insights in how you operate the building and the environment that you provide for the occupants of that building. So, any questions? Go ahead.
A couple questions. One is, obviously we're starting to hear a lot more about the analytics part. My question to you as a software or building automation software provider, to what level are you going with this? I mean, is it like an add-on to what you guys provide as part of your software package now to dive a little bit deeper? And then are you selling it? Are you selling that as an additional piece to do commissioning yourself, or how does it play with you guys as a vendor, as a provider?
That's kind of a loaded question. When you're working, so my primary job is to work like with design engineers, and design engineers aren't as much interested in that as sometimes building owners are. And then what happens is the costs that are involved with that ongoing commissioning and the ongoing analytics, that's where we're seeing the real hang up. So I will tell you, yes, we offer add-on services that are available to be used. We've got 2 or 3 different levels. We've got one that can be run within our system where we run rules-based type analytics. We also have subscription services. Like I said, the thing that we're finding right now with subscription services is facility operators really aren't interested in that ongoing cost. And I have to be honest with you, I'm somewhat of an old school guy, and I guess I kind of look at it as, okay, I can see doing this for a few months, but once I've got it going, can you show me why I need to continue to pay for this service? I understand there's entropy involved with degradation over a period of time, but from what I have seen, the subscription services are pretty expensive.
It seems to me, and it was an interesting point you were talking about, is that a service that we sell as commissioning authorities? And we're kind of used to going in and doing like a fixed thing and getting there and kind of getting done. So the idea of a continuous commissioning, it hasn't really been addressed, I don't think, as a professional, because we're not used to staying there long term. We'll come in and fix something, or we'll come in and do whatever we need to do, but then we kind of tend to walk away. So the idea of continuously monitoring something from a consulting engineering perspective is not like, it's not in our wheelhouse, I'll say. So,
well, and one of the things I want to bring up is, how many times have you gone into a facility to do like a retro commissioning? I've actually seen this happen. A VAV box isn't working. Owners complain, this box is not working. Okay, I'll go look at it. So I'll go climb up in the ceiling, and guess what? The actuator's pulled off, and there's a big wrench that's got the damper locked. Now, how is that my problem? But you see a lot of that going on in facilities, and if you're not doing continuous commissioning or even some FDD, you're not going to know those things are happening. And then to your point, I think it was Al, you were talking about, the building engineer leaves. He's got all that information in his head. He's gone. Nobody knows what's going on.
and I guess that's where I'm going, is that, we get paid. We go in as an engineer, let's say, and we're looking at stuff, and we find that. So that, okay, so then they hire and say, yeah, you found some problems, we'd like you to find more. So you go ahead and find it. You go through and you develop your issues or whatever, and you say, these got to be fixed, these got to be fixed. Now it's up to them to fix them. But the idea of continuously monitoring that stuff is just a little bit unusual. But I like the idea of being able to have the technology, I guess, or the software that does a deeper dive to be able to find those things. I'm just not sure, from our standpoint, how we take the most advantage of it. How does it work with us as consulting engineers? You know, I mean, you can see how it has advantages. I certainly think it has a lot of advantages for the owner. And then the question is for me is, well, do I buy a software package if I can get the owner to buy the software package? I mean, you know what I'm saying? I'm like, do I buy the package so that I can go in and do the deeper dive because he's not doing it, or do I do an add-on to what he already has to get that information and extract it? You know, it's kind of,
So as a design engineer, when I'm designing a project, I would encourage, at a minimum, at least to implement analytics that are a part of the base BAS system that don't require, subscription services, at a minimum. Now, if you want to take it a step further and go to the subscription services, that is also an option as well. Yes, sir.
My experience is people have enough money to do things they want to do. So I was talking to a building manager and he told me something that stuck with me. I'm going to share it with you. He said the reason that he can't implement retro commissioning or ongoing commissioning or continuous commissioning or any of these sort of after the fact tasks, he's represented himself to the leadership of his organization, and he's an expert in all things building, all things BAS. And so for him to say, I need to bring in a commissioning agent, I need to bring in an engineer, requires a little bit of humbling on their part. And so getting past that has been a bit of a roadblock for us. I don't know if anybody else has seen that or recognized it.
I think there's some merit to that, but I would also say, so there to me are a couple different facility type operators. There are the ones that I would call are a power user of a BMS system that really dive into the system, really dive into how equipment's operating. And then there are those that are just doing the PM stuff. The ones that are just doing the PM stuff, there are some of those, but the one that's a power user, yeah, I can see him saying, that's what you're paying me to do. But my experience has been those are few and far between each other.
My only comment, just because I've seen a lot of different systems, yours is a little bit kind of nice. I forgot what you called it, but you just have that one little meter, the environmental meter.
The environmental index.
So it actually is something that, and I guess that's a lot of things even with building automation. It's something simple that can be trained to an owner about what that number, it's kind of tell them what it is, but they can base decisions on that. Because analytics, just like almost sometimes building automation period, can just be so overwhelming to these people, and they have too many other things to do. This is the thing that they're just getting notified by.
That's what's driving the visualization or the dashboarding, is people don't want to have to spend the time to look through all of this trend data, look for what's going on. They want something to just pop up, an environmental index. Hey, this zone has an environmental index of 70. Something's wrong, I need to go look at it. Versus just going through there to see, am I at set point, am I less than set point, am I above set point? That's just a quick tool to help the user realize there's an issue that needs to be identified.
Wouldn't a properly set up BMS without fault detection serve that though? I mean, if you're setting your upper and lower limits on all your alarms and it goes out of range and then your alarm is generated, then what do you need this other software for?
Well, the FDD software or portion of a BMS system, it's actually looking at the alarms that are going on and deciding what alarms it needs to send up to the user. So, I talked some about the alarm suppression. So like in the chill water system, being a BMS manufacturer, I'm gonna set up all these alarms that you asked for, but I'm not gonna take the time to suppress them unless you tell me I need to do that. I'm just being honest with you.
That my owners have had with me was, they feel like they're already paying for this. Why would I pay more for something that I feel?
Well, I will tell you as a controls provider, the two places that I run into the most trouble are graphics and alarming. I either have too much information on my graphic or I don't have enough information. I'm either sending too many alarms or I'm not sending enough alarms. And that's just a balancing act that we as control suppliers have to deal with. So what I try to tell engineers is when you're specifying a project, go ahead and build a points list. And on that points list, in addition to putting your hard-wired I/O and whatnot, go ahead and put, I want to see this point on a graphic. Go ahead and make another column for graphics and say, I want to see this point. Go ahead and make another point for trends. I want to see this point trended. Go ahead and make another column for alarms. You know, when this point is out of range, I want an alarm. That makes it easier for us. I know that's what you as engineers are looking to do, to make it easier for us, but.
Run into the problem where it's specified that you'll have the capability, but if you don't tell them to include that trend, or don't tell them to include that alarm point, BAS contractors doing the project said, well, the system has the capability, but you didn't tell me the program was across from you. And so that goes back to my question on FED and analytics. You said that your system has certain capability. Is that the same for most of the major manufacturers of your competitors also?
Most of our competitors will have some sort of built-in analytics. Not everyone has got FDD yet. Everyone is doing alarms. And I would also say this, everyone has the capability of programming FDD into their system. I would start with using the standards out of ASHRAE 36P on a high-performance building. You know, you need to provide a hierarchical alarming FDD arrangement for this system, so that downstream systems, if you will, or components, the alarm gets suppressed for stuff upstream of it.
Yes, just another general comment. I would say the majority of us in this room, probably virtually all of us in this room, are the ones that are actually pressing the control contractor to actually get to some level. I mean, they're, you know, to actually have these alarms be functional in the first place, you know, and trending. If you're not on these folks even early, you know, with a page turn and all these other things, you know, to make sure that, you know, you're going to be on the spot to meet the intent of the spec, because you used the word yourself, you know, the capabilities, right? I think in the specification, it talks about like the 100% capability, right? And if you don't have, I'd say like the people such as us, I think they probably get about 5 to 10% of the capability. We probably stretch it up to maybe 40 to 50%. And then like some other people mentioned, the power users, right? They on themselves are the ones that elevate themselves up to the highest level. I mean, that's kind of how I see it.
I would agree. I would also add to that, having been involved on the operations side, something that I would really encourage you guys as commissioning agents, I try to encourage my project managers when I was putting projects in, get with your controls vendor as early as you can in the project. And the two of you sit down and talk about what stuff do I want to see, you know, trended, what stuff do I want to see in commissioning reports. If you will do that early, it will make things so much smoother at the end of the project. Because at the end of the project, what's everyone trying to do? Get off the project. And if y'all are fighting and arguing over, I don't need to do this and I don't need to do that, that's just wasted time. So I really encourage you as you know, commissioning agents, hey, come find us as the controls vendors and say, let's talk about, you know, what we're going to do in this system. Let's talk about what the graphics are going to look like. Let's talk about what alarms are going to look like. Let's talk about what trends are going to look like. Let's talk about what commissioning reports are going to look like. It's really important.
You guys never filed a change order for that?
I didn't, no. Because I will be honest with you, I found that when we did that, commissioning went a lot smoother and I spent less time commissioning the project. I'm going to go ahead and blow a little smoke at all of you right now. commissioning agents used to be the vein of my existence. I couldn't stand commissioning agents. And then I guess it was about 3 years ago, I worked pretty closely with a commissioning agent in Atlanta and really saw what he did for the customer. It was Atlanta Public Schools, and saw what he did for the customer. And it really just clicked with me. All you guys are trying to do is make sure the owner gets what he paid for. That's it. And that was kind of the mantra I started telling my project managers and my technicians. If you will put in what's specified and what the owner wants, there should not be any problems, and you shouldn't have to worry with a commissioning agent. So I gained a newfound appreciation for what you guys do and what you're trying to accomplish. So I think it's an important part of our business. So I think it's why it's more important for us as control vendors to work more closely with you to make this an easier process for all of us. So, any other questions, comments? All right, well, thank you guys. I appreciate your time. Have a good evening.